Hello and good day, pre-algebra. We are finally to the equation solving part of the unit. We spent the first half of the unit looking at expressions, looking at variables, plugging in values for a variable, checking to see if a solution works in an equation, how to cheat in math when solving equations, right? But now we're finally to the actual solving part. And this is where it all begins. N plus 6 equals 18. This is it, right? Because if you look at what's coming up, let's just preview, okay? We are going to not too much time get to much more complicated equations than n plus 6 equals 18, right? In book 3, we're going to get to equations that are about twice as long as what you see here. And the danger with solving equations is that when we start with something that's relatively simple, a lot of you can do this mentally, right? A lot of you already probably know what n equals because you can do it in your head. Yeah. Okay? I need you to learn the process on how to solve. It's nice to start with something you can do in your head because you can easily check it to make sure your answer works. Okay? But eventually we're going to get to equations you cannot do mentally, right? And you're going to have to rely on the opposite operations method or some other method to solve it. Is guess and check a good method to rely on when solving an equation? No. Okay, can you use it occasionally if you're in a bind? Yes. But if that's your only method that you know on how to solve an equation, things are going to get really, really difficult for you going forward. Okay, so we start with something like this that you can do mentally, just to kind of ease into it. But please, 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 please take this seriously. Show your work, learn the process. Right, it's going to make everything a lot easier going forward. There's my speech. Here we go. N plus 6 equals 18. We're going to look at three kind of different ways to approach this. And the first one is simply logic, probably what you did in your head when you first saw this. Okay, what is the expression as a question? As a question, kind of going from the mathematical to the verbal. Anyone have an idea? Yeah. Right, and since I want it as a question, I want to just replace the word a with what. You can think about this as what number plus 6 is 18. Right? What number plus 6 is 18? Anybody? 12. 12 plus 6 is 18, right? And therefore n will equal 12. That's essentially the question that you're asking. Whenever you want to solve for a variable, you're asking, what can I plug in there that makes this equation true? Okay? And is 12 the only value that makes this equation true? Is 12 the only number that when you add 6 to it, you'll get 18? Yes, it is. Okay? So you're only looking for the one number that makes this equation true, and logically looking at it, thinking about it, you can just kind of answer that question. Again, it's nice because you can do it mentally, okay? But that's the logic behind it. Opposite operations. This is the one that we're going to focus on going forward. And Anthony kind of introduced this to us earlier when he said what opposite operations is. We're going to start by rewriting the equation. N plus 6 equals 18. And Anthony, what did you say we're going to do here to get n by itself? I would do 18 minus 6. Yeah, that's what I would do too. Okay. And the reasoning behind the opposite operations method is you can think of that equal sign as kind of like a balance scale that you may have used in science before. Have you ever used a balance scale in science before? You weigh things, balance things. You know, it looks forgive my artwork here, but it looks kind of like this. It's got little things on each side, right? Thank you. Okay, and thank you. And this equal sign is kind of like that center post, right? And what this equation is saying is that on one side we've got some number plus 6. On the other side we've got 18. And the equal sign tells us those things are balanced, right? They equal the same thing. They weigh the same. They have the same value. And so the idea behind opposite operations is that we want to know what n equals which means we want to get n by itself. Okay? Now, Anthony, why would you subtract 6 from this equation?
It would give the other number.
So 18 minus 6 equals 12, but then what do we do on the left side?
You put 12 there.
Not quite. If we subtract 6 from the right side, and we want to keep this equation balanced, what do we have to do from the left side? Subtract 6, right? Whatever you do to one side of the equation, you're doing to the other, because you're moving that 6 over to the other side. When we subtract 6 from the left side, what is 6 minus 6? 0. We've removed it, right? We've taken it away from the left side of our scale. So now all we have left is n. And if we don't subtract 6 from the other side, what's going to happen to our balanced scale? Boom, right? It's going to be not balanced anymore, and that's a problem, okay? So we have to subtract 6 from the other side also, and that gives us 12, and that tells us that n is equal to 12. N is equal to 12. Okay? Here's the most common mistake that folks make with this. Is instead of subtracting 6, they add 6. Okay? Tell me why mathematically that is incorrect. Does adding 6 to that left side achieve the goal of getting n by itself, Anthony? No. What happens?
You'll get the n would be 24.
Right. Well, on the right side, we get 24, and we get 18 here, right? But 6 plus 6 equals 12. So now we have n plus 12 equals 18. That's not really helpful, is it? Okay. So the opposite operations method, you want to cancel that constant out, cancel that 6 out so n is alone. That's what you want to do. Okay. Does that ring a bell from last year? Yeah? Good. Good. Okay. The third and final method that we'll talk about is fact families. Do you remember writing fact families for addition, subtraction, probably in your like second or third grade? Okay. They look like this. Maybe you haven't before. But if we start with n plus 6 equals 18, those that remember these, what would be another family member of this fact family? Basically, how could we rearrange those same 3 numbers, same 3 terms, to get a true statement? Anthony?
18 minus 6.
Yeah, we could write this as 18 minus 6 equals n, right? If n plus 6 is 18, 18 minus 6 equals n. What else could we write? 6 plus n equals 18. And what else could we write? Gregory? Good. 18 minus n equals 6. Basically, a fact family is it's taking 3 terms and writing all the true statements that you can. If n plus 6 is 18, that means 6 plus n is 18. It also means that we can get n by subtracting 18 and 6, or if we subtract n from 18, we'll get 6. Anthony, bubbles, man. Okay? So the fact family are all those true equations that we can write. And if you'll notice, the one that's most helpful to us, this is a family. You all have that family member, and I don't want any names because we're recording, it's forever. But you all have that family member that's not very helpful.
Yeah.
Maybe it's you, hopefully not. But right, you all have that family member that's not very helpful, but you also have that family member that's super helpful. The one that's always getting things done. Which is the super helpful member of this family here as far as our purposes of solving for n goes? Zoe. Yeah, 18 minus 6 equals n. Why? Because n is by itself, and 18 minus 6 equals 12. That's the exact same thing we did here in opposite operations, right? We took that most helpful member of this fact family, and we used it in opposite operations to get 12 as an answer. We still love all the other members, but we like that one best. Anthony.
Could you do 18 plus -6?
18 plus -6. Yes, that's the same thing as what this says here, right? Because adding a negative is the same thing as subtracting. But could you write it? Yes. That'd be like the second cousin of the family. Yeah. All right. Questions on any of this? Again, this is where our solving equations journey begins. All right. Using two of the methods from above each time, solve for the variable in the equation. Let's, for this first one, let's use the logic method and opposite operations. Okay? Logically, what is this asking us to do? Logically, what is this asking us to do? If you were to phrase this as a question, what would that question be? Yeah.
8 plus n equals 20. 8 plus number equals 20.
Yeah. 8 plus what number is 25? Right? That's essentially what the equation's asking. We add something to 8 and we get 25. Who can answer that question for us? 8 plus what number is 25? Anyone new today? You can? 17. Okay? Ta-da! Mental math, right? But because we want to learn the process, we're also going to use opposite operations, or the op-op, as I like to abbreviate, op-op. Okay? And op-op says 8 plus n equals 25. We want to get n by itself, which means we need to move this 8 to the other side. Okay? And what is the opposite of a positive 8? A negative 8, right? We're going to subtract again here. If we add 8 to both sides, did we cancel that 8 out? No. What's 8 plus 8? 16. That's a problem, right? We want to get rid of it. We want to get n by itself. So we're going to be subtracting 8 from both sides because 8 minus 8 equals 0. And then in order to keep this equation balanced, 25 minus 8 equals 17. N equals 17. Okay? Then we can rely on PO15. We can say, does this work? We can cheat, right? Does this work? Did I get the correct answer? Well, does 8 plus 17 equal 25? Check it does. Okay? Very good. Next one. Let's use logic again. What's the question being asked here? Or how could you phrase this equation in question form? Yeah. Good. What number minus 13 is 19? What number minus 13 is 19? Nolan, what's the answer to that? 32. 32 minus 13 equals 19. Okay. Now, if you in your head were thinking 6, right? Because sometimes when our brain sees an equation, it jumps to what's comfortable. It jumps to what it knows. It sees the 19, it sees the minus 13, and your brain might just jump to 6 because 19 minus 13 equals 6. That's the value of checking it. If you plug 6 back into this equation, is 6 minus 13 19? No, right? So the importance of checking is that when you make a whoopsie-doo, which we all do, right? You can catch yourself by pulling it back in and making sure it's correct. Mental mistakes will happen. They happen everybody. You can check it by plugging it back in. Using opposite operations, or op-op, n minus 13 equals 19. We need to remove that negative 13 from the left side. Remember yesterday we talked about that with subtraction and addition really, but more importantly here, that sign belongs to the 13. Since it's a negative 13, what's the opposite of that? Opposite of subtracting 13 adding 13, right? In this case, the opposite operation of subtraction being addition, we're going to add 13 to both sides. Because negative 13 plus 13 gives us 0. N is by itself, and 19 plus 13 equals 32. 32 minus 13 equals 19. Check. Done. Questions so far? Anthony?
Could you just like try to like get the 13 and just like put it to 19? Like just add it to 19.
Yeah, and that's essentially what we're doing, right? We are adding 13 to 19.
Yeah, but I don't think we have to like do the
Show all the work?
no like adding the 13 to the negative 13.
You do. Okay? And the reason why, Anthony, is because this is only the beginning, right? Where we're headed, you're going to need to know the process. You're not going to be able to do the equations mentally. Okay? And if you don't know how to do the process, you're going to be stuck. Okay? How old are you? How old are you?
13.
13. So you've been alive for 13 years. I've been teaching this for 16 years. Trust my experience that those that try and cut corners here because, hey, this is easy. I can do this in my head. Why don't I show the work? Show the work. Okay? Because those that don't show the work now get stuck later on. Trust me. Do you trust me, Anthony?
Yeah.
Good, Anthony. Will you show your work, Anthony?
No.
Show the work, Anthony.
Just keep it.
Okay. All right. Okay. Another hand up. Ryan, William, was one of you? Did you have your hand? No? Okay. Last one. N plus 12 equals 50. Again, let's do, actually, let's not do the logic. Let's do op-op. Okay. N plus 12 equals 50. Go ahead and use opposite operations to solve for n. Show the work, please. Show the work. You want to get n by itself. And what's going to be required to do that? Raise your hand when you have an answer to that. Peyton.
I'm doing subtraction.
Yes. Subtract 12 from both sides, right? Because 12 minus 12 equals 0. We've canceled that out. N is now by itself. And 50 minus 12 equals 38. Okay? Prove it to me. Okay. 38 plus 12, plugging that back in, equals 50. Checked it. Right? Let's use fact families for this, because I don't want them to feel left out. Our first member of this family is n plus 12 equals 50. What's another member of this fact family?
12 minus 50 equals n.
Wouldn't be 12 minus 50 equals n. 50 minus 12. Remember in the part whole adding here, a part plus a part equals whole, it'd be whole minus part equals part. So the other one we could write, starting with 50, is 50 minus n equals 12. And then what's the last? 12 plus n equals 50. Just kind of switch around our first one. What's the most helpful member of this fact family here? 50 minus 12 equals n, because n is by itself. It's the exact same calculation that we did there in opposite operations. And 50 minus 12 equals 38, which is the answer we got. So that's good. Okay. All right. Your homework it's going to be checked in on Monday because I won't be here to check it in tomorrow. But we will go on to PO17 tomorrow. You have a video to watch and everything like that. Your homework for tomorrow is the second page. You've got 12 of them to do. I require that work be shown. It is in the directions here. as well as checking your answer. Okay, so where we put the check marks on the front page, where we plugged it in, made sure it worked. I want to see you doing that. I also must see the work. It says time to pick a favorite using only one method from above or from the previous page. And you can switch it up as you go, solve each equation. So if you want to do one with logic, write the question, answer it. You want to do one with fact families, write the family members, circle the most helpful one, answer it. Or if you want to use opposite operations, you can use that one too. Okay, opposite operations is the one that we're going to use most going forward. So I'd recommend using that one, but you can use any of the three. Then you've got some word problems at the bottom. The number of baseball cards in a limited edition collection is 100. You already have 36. How many cards do you need to complete the set? Today is -3 degrees outside, and tomorrow will be -11 degrees. How many degrees colder will it be tomorrow? Okay, so a little bit of application. These are called one-step equations because it takes one step to solve them. Tomorrow we'll look at one-step equations with multiplication or division. So again, bring your headphones for a very rousing video of me teaching the lesson. And then that's that. Khan Academy due tonight. This is homework for tomorrow. That's how you math.